This is section 12, function analysis, example 6. So this is going to be an example where we actually use the mean value theorem in real life. So one of these ideas is the average speed that your car is driving and the resulting instantaneous speed that it must have gone at a particular moment in time, right? Because we know that if we travel a certain amount of miles in a certain amount of time, at some point it would have reached that average mile per hour, right? Because if you drive, and I bet a lot of you do, then your speed, your average speed, has to represent the speed that you went at a particular moment in time. We might not necessarily know what that moment in time is based on the information, but we know that it happened. So we're going to use the mean value theorem to show that a car travels 110 miles. A car that travels in 110 miles in 2 hours must have had a speed of 55 miles per hour at least once during the 2 hours that it was driving, because 55 miles per hour ends up being the average velocity. And so that's what we're going to do first. We're going to say that I'm going to use S equals f of t to represent the distance traveled. Okay, just so that I have something to reference. Now, I know that the average velocity which is the same thing as the slope of the secant line for a real life situation, is f of 2 minus f of 0 over 2 minus 0. And that's really all the information that they give me in this problem. They tell me that a car travels 110 miles in 2 hours. That gives me my final time and distance, and my initial time and distance, I'm assuming, is going to be 0 because it started at 0 distance. So that means I have 110 minus 0 over 2 minus 0, which is 110 over 2, which is 55 miles per hour. Now, if the average speed is 55 miles per hour, then our reasoning tells us that at some point you must have gone 55 miles per hour. Okay, you must have. At some point. You could have gone slower, you could have gone faster, you could have gone... Well, you would have had to go slower and faster to get there. But that's our average speed. Okay? So at some point, you would have had to cross 55 miles per hour. So I'm going to use math now to justify. So by the mean value theorem, there is a time I'm going to call it T naught, where 0 is less than T naught, which is less than 2, so between 0 and 2 hours, such that, so I'm going to use ST for such that, f prime of T naught is equal to f of 2 minus f of 0 over 2 minus 0, which is 55 miles per hour. So this supports that. This is saying that the instantaneous rate of change is equal to the average rate of change at a particular moment in time.